Hola a todos los ingenieros de mantenimiento, responsables de operación y mantenimiento, y profesionales técnicos. Nos enfrentamos a un desafío crítico en la era de la inteligencia artificial: la desconfianza cuando la IA toma decisiones sin contexto o transparencia. Esta falta de visibilidad obstaculiza la adopción plena de sistemas inteligentes.
Traditional AI, often perceived as a black box, generates decisions without explaining its reasoning. This impedes trust, hampers auditability, and limits our ability to correct errors or improve the system. A technician cannot validate a recommendation without understanding the context. This opacity can lead to resistance to following AI recommendations. It also complicates auditing automated decisions, making it impossible to trace the process. Without understanding the model, continuous improvement and error correction become arduous tasks. The risk of unnecessary or late downtime increases significantly. The economic and operational loss due to incorrect interventions is a direct consequence of the lack of explainability. We need a solution that transforms AI from a black box to a transparent collaborator. The solution we will discuss is the Explainability and Interpretation Agent. This component is a dedicated layer within the multi-agent system. Its fundamental purpose is to demystify AI decisions, making them understandable to the technical user. The main role of this agent is to translate complex AI models into understandable technical language. It generates detailed and contextualized reports, providing the why behind each recommendation. Thus, the system not only predicts, but also explains. The Explainability and Interpretation Agent performs vital functions in bridging the gap between AI and the end user. Its primary function is the translation of complex models. It converts neural networks and advanced algorithms into clear and accessible technical concepts. It identifies the key data points that influence a prediction. This allows the user to understand which variables were decisive in the AI's decision. It provides a clear view of the most relevant factors. It also generates customized reports tailored to different audiences. A technician will receive a report with operational details, while a manager will receive an executive summary. This customization ensures the relevance and usefulness of the information. This agent guarantees complete traceability of all automated decisions. Each AI action is recorded with its context and justification. This is essential for follow-up and subsequent review. Finally, it ensures the improvement of being audited for all the decisions it has made. The ability to trace the decision-making process is crucial for regulatory compliance and internal validation. Explainable AI fosters trust in predictive maintenance systems. Specialized subagents operate within the Explainability and Interpretation Agent. These components work together to generate detailed explanations and understandable reports. Its modular architecture allows for great flexibility and efficiency. The Predictive Explanation Subagent is responsible for analyzing predictive decisions. This includes fault diagnoses, maintenance recommendations, or operational changes. Its objective is to break down the system's reasoning. It extracts the key variables that drove the decision. For example, if a failure is predicted, it will identify the sensor parameters or operating conditions that led to that conclusion. This provides a technical rationale. It generates explanatory sentences that summarize the system's reasoning. These sentences are concise and use specific technical vocabulary. They allow the user to quickly understand the why of the prediction. An example might be a prediction of gearbox failure in 72 hours. The subagent would explain that this prediction is based on an 18% increase in countershaft vibrations, along with an anomalous thermal pattern. It might also indicate that it matches 6 similar historical cases in the same model. To achieve this explainability, advanced technologies are used. Interpretability algorithms such as SHAP, Shapley Additive Explanations, and LIME, Local Interpretable Model Agnostic Explanations, are fundamental. Attention-based natural language processing is also used to generate coherent sentences. This subagent uses a history of real failures as a knowledge base. This allows it to identify patterns and relevant histories. Explanatory templates tailored to the user profile ensure that the technical vocabulary is appropriate. The result is that a technician does not receive a blind order, but rather a reasoned alert, with history and recommended actions. This allows the prediction to be validated with expert knowledge and facilitates the correct prioritization of interventions. It increases confidence in the system's prediction and allows for planned, non-urgent interventions. The subagent for operational and technical reports is the next link in the explainability chain. It collects the predictions explained by the previous subagent and converts them into automated reports. Its role is to structure and present the information in a useful way. It adapts the language and format of the report according to the recipient's profile. A field technician needs specific details, while an O&M manager requires a summary without going into detail. This customization is key to efficiency. The output formats are varied and flexible. It can generate detailed technical PDFs for documentation. It can also feed real-time dashboards for continuous monitoring. In addition, it issues alerts for critical situations and generates monthly reports for analysis. An example would be a monthly technical report for a turbine. This report would summarize the month's key issues and recommendations. It would include explanations of the most important predictions and the actions taken. This subagent interacts with other agents in the multi-agent system. For example, it communicates with the intelligent maintenance agent to obtain operational data. It also collaborates with the orchestrator agent to coordinate report generation and distribution. The key benefit of these automated reports is the reduction in analysis time. Technicians can focus on higher-value tasks instead of spending hours collecting and organizing data. A technician doesn't receive a simple order, but rather an alert with context, precedents, and recommendations for action. AI explainability is not just a theoretical concept. It has direct and tangible applications in everyday operations. It enables more informed decision-making and increased efficiency. Consider a critical scenario. The AI system predicts an imminent turbine failure. Without explainability, the alert would simply be, "Stop turbine 14 in 6 hours." This creates mistrust and resistance. With the explainability agent, the alert is accompanied by a clear justification. For example, the system recommends a turbine inspection due to an 18% increase in lay shaft vibrations and an anomalous thermal pattern in the gearbox. It is added that this situation coincides with 6 similar historical cases. This detailed information allows technicians to understand the rationale behind the recommendation. They can validate the prediction with their own experience and knowledge. This facilitates intervention planning, such as scheduling an inspection or preparing spare parts. Explainability transforms a simple order into an informed decision. It enables proactive action, anticipating unplanned downtime. Trust in the system increases, resulting in greater adoption and operational efficiency. The ability to audit AI decisions is critical for governance and regulatory compliance. Explainability provides the necessary audit trail. Suppose the automated system decides to shut down a turbine due to a critical condition. Without explainability, this action would be difficult to justify or investigate. With explainability, a full traceability report is generated. This report would include the data used for the decision, such as sensor readings or behavior patterns. It would detail relevant historical context, such as similar past events. It would also record the system's reaction time and the actions taken. The traceability report allows auditors to verify the logic of the decision. They can confirm that the AI acted within the established parameters and that the justification is sound. This is crucial for accountability and continuous improvement. AI not only makes decisions, but also leaves an auditable trail. This trail is essential for complying with standards such as ISO 42001, which requires auditable and explainable AI systems. Transparency is the foundation of trust and accountability. Implementing explainable AI not only improves understanding, but also generates measurable and significant benefits. These benefits directly impact operational efficiency and staff confidence. This can increase confidence in automated decisions by up to 40%. This has been measured through surveys of technicians and O&M personnel. Greater trust translates into greater acceptance and use of AI recommendations. A 25% reduction in alert rejection or ignorance can be achieved. Lack of context is the main reason alerts are ignored. Providing clear explanations ensures that staff act on critical information. A 60% improvement in the speed of corrective action can be achieved. By understanding the why of an alert, teams can respond more efficiently. This reduces response time and minimizes the impact of failures. Furthermore, explainability facilitates regulatory compliance. Emerging standards like ISO 42001 require auditable and explainable AI systems. Good design can demonstrate the transparency and accountability of on-premises AI systems. Transparent AI is powerful AI. It's not just about making decisions, but about making decisions with arguments. When AI is explained, technicians trust it. And when they trust it, they act more safely and effectively.